Alright, welcome to my video here on Chapter 2. Let's start with creating a frequency distribution. Okay, here's a problem that I cut right out of our textbook. They're asking us to create a frequency distribution. They tell us the number of classes. Alright, you're always going to be told the number of classes. In the real world, you would have to pick something. The guideline in the book is somewhere between 5 and 20, but anything we do in here, you're going to be told the number of classes. The key to getting one of these right is getting the class width right, and there's kind of two different ways that I mean that. So let's start. First, the first thing you got to do is find the range, the high and the low. I highlighted these two for us, so just getting started. So in this case, that's 120 minus 65. Equals 55. Then the class width is going to equal the range divided by the number of classes. Then round up. Okay, so let's see what I mean by that. So the range is 55. The number of classes is 6. We do that division. 55 divided by 6 is 9.17. Round up means don't follow normal rounding rules. It means go up to the next integer. So our class width equals 10. This is important. Okay, this is important. Even if this had come out to be exactly 9, we should have said 10 for the class width. If you don't round up, there won't be enough space for your data. It messes things up. All right, so this is the first part of what I mean. Okay, the second part. Start your classes. That's the first part of what I mean by class, getting the class width right. So we know it's 10. Okay, there we've got the first part of it right. Now your first class starts that your first lower class limit equals the minimum value in the data. Okay? All of this, by the way, is on page 38 in our text. Okay, so the first one is the lowest value. Then a class width of 10 means the lower class limits, you're just going to keep adding 10. So 65, 75, 85. Remember, we want 6 classes, right? 95, 105. That's 5 classes, 115. So what do you suppose the upper class limit is? Well, you just go up to just below that, right? That's 75, so this is 74. Here, the next class starts at 85, so this one's 84. And you'll notice these will all go up by 10 too, right? Okay, so a class width of 10 results in the width going across here, right? That's 9, 65 to 74. That's where people will. That's the other place people will mess this up. You got to calculate the number correctly. Then you have to realize that class width is going down. It's from here to here, from here to here, etc. Right? It's from the lower limit of one class to the lower limit of the next. Or if you wanted to, I guess you could do the upper limit of one class to the upper limit of the next. All right. Now that we have that, it's really just turn the crank. So now we're just going to count how many of the data points fall in each class. I just use tick marks like they do in the book. 68 goes there. 105 is going to go there. 95 will go there. 80 goes here. 90 is in this class. 100, second tick mark in that one. 75, 70, 84, 98, 102, 70, 65, 88, 90, 75. See, we're just recording as we go along here how many, where they each fall. 78, 94, 110, 120, 95, 80, 76, and 108. Okay? So, here's our answer then. Our classes, 65 to 74, 75 to 84, 85 to 94, 95 to 104, 115 to 124, then our frequency is 4, 7, 5, 3, 1, and there is our frequency distribution for this question. Okay? There's lots of other little details they can ask you about. What are the boundaries? What are the midpoints? All this kind of thing. All this stuff, right? If you get questions about that, go back and look in our textbook. They define that stuff very cleanly on page 38 and 39. It starts on page 38. But the thing I really wanted to show you was the two things with the class width. When people make a mistake on these, either what happens is their mind wandered and they lost track of a point, or they messed up something with class width. Almost every time it's one of those two things. All right. The next thing I want to talk about is really an idea, not so much a difficulty. Talk about a little case study I made up here. Which is a better measure of the center or middle of a distribution, the mean or the median? So let's look at this. We've got 24 customers in a restaurant. Okay, this is going to be about the income of those customers. So the average income of the customers is $60,000 a year. Okay, that's the average. The median income, $54,000. All right. Which is the better measure of the center or the middle of this distribution of annual incomes? Well, usually what we say for this one is you would say the mean. Okay. The mean uses all the information. Okay. I'm sorry, I should have been a little more careful here. When I say average, that means the mean. Okay. The mean here is usually the 1. Now, there's an exception which we're going to get to in a minute. But the reason, if there's not a problem, the reason we say the mean is that it uses all the information. Okay? It looks at every individual number. It performs a calculation that uses them all that kind of stuff. Okay. Now, let's change the situation a little bit. Let's say a superstar professional athlete walks into the restaurant who makes $25 million a year. Now, what's the average income? Well, you do a little calculation, you can find the average income's over $1 million a person, right? The average income's over $1 million. So we had these 24 people whose average income was 60. Now we've got these 24 of them, the same people. The average income is suddenly over $1 million. All right. What's the median income? Well, the median income is just going to slide to the right up to the next highest income, right? So whereas before this 54,000 was the average between, say there were 24 of them, was the average between the 12th and 13th highest income in the room. Now it's going to just move to the 13th highest in the room. Okay. So it's probably going to shift just up a little, maybe it goes to 60,000, maybe it goes to 57,000. Something. It's typically just going to move a little bit, not a whole lot. It might not move at all. Maybe the 12th and 13th highest, maybe these two different people make the same amount. It's going to be pretty close though. So now what's the better measure of the center? Well, if you try $1 million, 24 of the 25 people make way less than that, right? Not even close. And the 25th one makes way out there. I mean, in this case, it's going to be the median. All right. So here's the general rule. With no outliers, the mean is a better measure because it uses all of the information in its calculations, so it's more accurate. With outliers, the median is a better measure because the mean is too strongly influenced by outliers. You see that this one high value here of 25 million blew the mean through the roof. Okay, so the mean is very influenced by outliers. That's why with no outliers, the mean is the better measure. If there's outliers, the median is the better measure. All right. The next thing I want to talk about is standard deviation. There's kind of two separate pieces about this. One is calculating it correctly, and then the other is what is it. For the calculating it correctly, I've got a video for you. How to use your TI 83 or 84 calculator to find mean, range, standard deviation, median, quartiles, and the 5-number summary of a data set. All of that you can do in using one easy function in your TI 83 or TI 84 calculator. This link here will take you to a video, a YouTube video. It's not mine. It'll show you how to, but it'll show you pretty cleanly how to use a function, one variable stats in your calculator. Actually, first it goes through showing you how to enter the data points into the right place in your calculator, and then you do the one variable stats function. The whole video is less than 5 minutes. It'll show you how to find all of that stuff. Okay? If you pay attention, you can see real clearly on the video which buttons to keep pushing. All right. So that's what I recommend that you do with that. Now, little note here. If you need the variance, just use the calculator as this video shows to get the standard deviation, and then square that number to get the variance. The one catch, be sure to get a few extra decimal places in the standard deviation before you square it so that you don't get a rounding error in your final answer for the variance. In other words, you're in my math lab, they ask you for the variance to 2 decimal places. Well, use the standard deviation to like 5 or 6 decimal places. Square that, get the variance, and then round it down to 2 decimal places. That'll get you the right answer. The link for this video here is also, for this YouTube video, is listed in my video links file in Blackboard. Alright, so that will show you how to get the right numerical answer. You're going to need to understand what standard deviation is actually measuring. In a way, what it's measuring is how spread out, speared out, let's try spread out the data is. Okay? If all of the data is the same value, let's say you got a data set and every single piece of data is the number 7 or any other value, right? The standard deviation is actually going to be 0 because there's no spread to it whatsoever. The more spread out it is, all right, there's one data set. The more spread out it is, here's another one. Right? The more spread out it is, the bigger the standard deviation. Okay? I'm not sure what it would be here. Let's say the standard deviation was x here. Here it would be something like 2x. It's just going to keep getting bigger. All right? So that's the idea. If all the points are the same, the standard deviation would be 0 because it can't be negative. And then after that, the more spread out the data gets, the bigger the standard deviation. It's pretty close to the average distance from the point to the mean. Okay? It's not exactly that for various, and it is what it is because it makes some other things work out well with things like the normal distribution and some other things we'll do later. But it comes out to be pretty close to the average, to the distance from the average distance from a point to the mean, whatever the mean turns out to be. Alright, that's it for this video. I got 2 more things I want to do. I'll do them in a part 2 of this video. The next video, part 2, will be much shorter than this one. Hope you found this helpful, and be sure to check out part 2.